Hello everyone. Welcome to the next lecture on the transportation problem. In this lecture, we will cover the 15 plus numerical examples related to how you can solve the transportation problem using least cost method. Myself, Dr. Harish Garg, you can follow and subscribe my YouTube channel where you can find the playlist of the optimization technique. The last lecture was on the examples of the northwest corner methods, mathematical formulation of the transportation problem, and many more lectures available in this playlist. You can follow and watch all these lectures very easily. Now, what is the transportation problem? We have learned in our last lectures, whenever you have a capacity and the requirements such that the Cij is the transportation cost from the origin OI to the destination DI. The target of the transportation problem is to find the optimal allocations so that you can minimizing the transportation cost. Always remember, if your problem is maximization, then your target is to convert into the minimization problem. How we can convert? How you can convert the maximization into minimization, we will see in the couple of the numerical example in this video as well. Make sure students, whenever you have to find the optimal allocation, your first target is to find the feasible solution, because whenever you are dealing with the optimization technique, your first solution must be the feasible and then work on the optimal solution. How you can find the feasible solution? We have the three different methods. The first method is a northwest corner, least cost method, and the Vogel approximation. The northwest corner method is our last lecture we have learned with the help of the 15 plus numerical examples. Now, in this lecture, we will cover the least cost method. But make sure students, whenever you want to apply any of these methods, your transportation problem must be balanced. What is the meaning of the balanced? That means the sum of the capacities, AIs and BI. That is, you can say the sum of the AIs and sum of the BI must be same. On the other hand, the transportation problem is said to be the unbalanced whenever they are not same. And whenever the transportation problem is unbalanced, then your target is convert into the balanced transportation problem. I will explain you all these concepts with the help of 15 plus numerical example in this lecture. You can watch till the end so that you can learn the concepts along the various examples in an easier manner. You can see this is the same example that we have discussed in our northwest corner method. I have explained you all these 15 plus examples that I had solved in the northwest corner method. I can solve the same example with the help of least cost method so that you can compare the various costs along these various lectures. Now, first of all, your target is to identify whether your transportation problem is maximization or minimization. We always need a minimization problem. So since nothing is given to you about this problem, that means my problem is minimization. अगर कोई maximization होगी तो लिखा होगा whether they are the profit, whether it's a maximization. Fine. Now your target is to find the initial basic feasible solution. That means you can apply either as the northwest corner method, either you can apply the least cost method, or you can apply the Vogel approximation method. Because our target is to understand the least cost method, so I can solve each problem with the help of the least cost method. Firstly, we can check whether the problem is balanced or not. What is the demand total is 150. What is the supply total is 70, 90 and 150. That means my problem is balanced problem. Fine. Now, once it is a balanced problem, then how we can find the initial cost using the least cost method. Fine. So as the name suggested, your target is to find the least cost. You can look about these numbers. These are basically my cost. Look at the least number. That is, what is the minimum element in the cost? Can you find the minimum element in the cost? Minimum is 1. You can put the allocation corresponding to 50 and 40. What is the minimum of 40 and 50? Minimum is 40. I can put as 40 here. This is 0 and the remaining element is my 10. Now look at the second minimum elements. Second minimum element is my 2. Again, this is my 2 and these are my 2. There are the 3 observations. Fine. If I look about these 3 observations, fine. Now always remember students, whenever there is a tie between the cost, fine, then we can always choose with the maximum allocation. Fine. Always remember we can choose with the maximum allocation. Like what is the value is 60 and 30. Minimum is 30. What is the allocation is 30, 20 and 60. That is my 20. And for this case 40 and 60 is a 40. What is the maximum value? You can see the 40 is my maximum. So I can start firstly at this point. This is my 40. This is my 0. And this number is my 20. Is it okay? Now look at the second, this is the 22 and 2. Again, because there is a tie, we can find the maximum allocation. At this point is a 30, at this point is 20. I can put this number is 30, remaining is 30. Now look at the next number. Again, you can see 2, 20 and 30. I can say is that 20 is the minimum and the remaining element is 10. Now look at the next number. This is my 3. Fine, this is my 3 and this is again 3. But you will know there is no allocation at this point. Why? Because there is no supply. Supply is already over. Can you find this allocation? Yes. 10 and 20. Minimum is 10. In this case, there is no demand. That means there is no allocation at this point 3. So the only number is my 10. Minimum of 10 and 20 is 10. So allocation is 10. Now look at the next number is these 4 and 4, but there is no supply. So there is no elements about this point. Now look at the 5. Again, there is no supply. 6, there is no supply. The last number is 7 and 10 and 10. Now you can see all the demands are over. All these supplies are over. And how you can check your answer in the examination? You can see initial was 40. You can see the allocation 40. 40 plus 10, 50. 30 plus 20 plus 10, 60. Similarly for the row wise, 30, 40, 20 and so on. Fine. Now, what are your allocations? How you can write the allocation? The same way as we did in our northwest corner method. This element will be x13, which is equal to 30. Next element is x22 is my 40. This number is x33 is my 20. X41 is 40, X42 is my 10, X43 is my 10. Now once you can obtain this allocation, your target is to identify whether they are non-degenerate or degenerate. Fine. So you can check. You can check whether the allocations are equal to m plus n minus 1 or they are less than equal to m plus n minus 1. What is the m is? M is the number of the rows in the balanced transportation problem. N is the number of the columns in the balanced transportation problem. Always remember in the balanced transportation problem. In this particular example, what is the M? How many rows are there? 1, 2, 3 and 4. Number of the columns are 1, 2, 3. So therefore, what is the value of the m plus n minus 1? That is my 6. And you can see allocations are 1, 2, 3, 4, 5, 6. So you can see they are same and hence my initial, therefore the allocations are non-degenerate. And our target is also to find the non-degenerate solution. Fine. Once you can find the non-degenerate solution, therefore the initial cost will be, you can multiply them. 30 into 2, 60. 40 into 1, 40. 20 into 2, 40. Plus 40 into 2, 80. 10 into 3 is a 30 and 10 into 7 is 70. So whatever the answer you have obtained is the initial feasible solution of the problem. Make sure student this is the only feasible solution, not the optimal. whenever you want to find the optimal solution, then you have to read the concept of UV method, and that lecture I had already uploaded in Hindi. Hindi में already lecture uploaded है. Modi method is also known as the UV method. Now look at the second example. Find the initial basic feasible solution of the transportation problem. So nothing is given to you. That means that my problem is minimization. And how you can find? I can use the least cost method. Firstly, we will see whether this is balanced or not. It's a 190. From this case, it's a 90. It's a 120. It's a 210. So clearly say this problem is my unbalanced transportation problem. And then your target is to convert into the balanced transportation problem. How you can convert? Because there is a capacity is less, so I can add the new capacity, that is a W4, with the allocation. What is the difference between them is 20. Because my problem is minimization, and we all know cost value can never be negative. So the minimum cost is my 0. So I can add the dummy row. This D4 is called as dummy row. Fine, the costs are my 0, allocations are my 20. Now you can see now it's a balance. So let's start with the allocations. Minimum element is 0. So you can check which one is satisfied. Is the maximum. It is a 20. This is my 20. This is my 20, and this is again 20. So you can choose any number. So let's start with the here. Fine. This is my 40. Because सभी में maximum value same ही है, तो आप कोई भी choose कर सकते हो आप. Now look at the next smallest number is 13. Fine. So what is that? It's a 40 and 40. So allocation is 40. Minimum of 40 and 40 is 40. Next number is 14, but there is no sale, so you can cancel them. Next number is 15. 15. These are the two numbers. But corresponding to this 15, there is no capacity. So we can never add the allocation at this point 50. On this 15, 30 and 60. Minimum is 30. 30 and 60. Next smallest number will be 18. Fine, there are the two number 18, but corresponding to this 18, there is no sale. Corresponding to this 18 is a 30 and 50. Minimum element is 30. Allocation remaining is 20. Next number is 19 and 19. But corresponding to this 19, there is no capacity. Corresponding to this 19, there is no sale. Look at the next number is 20. Corresponding to this 20, there is no allocation. There is no sale. And corresponding to this number is 20 and 90. Minimum is 20. Remaining is 70. And corresponding to the 21 is a 70 and 70. लास्ट पॉइंट पे आपका जाके दोनों बराबर कटने चाहिए. फाइन, अगर कहीं मिस होता है तो इसका मतलब आपकी कैलकुलेशन मिस्टेक है. फॉर एग्जाम्पल, अगर कहीं पे जाके मान लीजिए ये 75 रह जाता तो इट विल बी 70, तो 5 रह गया ना, बाकी तो सब कैंसिल हो गए. इसका मतलब ये कहीं कैलकुलेशन मिस्टेक हुई है. क्लियर? Now you can see how many allocations you have. Allocations are x13 20, x14 70, x21 40, x32 30, x33 30, x41 is 20. Find how many rows, because this problem is my balanced. ये problem तो balance नहीं ना थी. This problem is my balance, so I can calculate the m 1, 2, 3 and 4. N number of the columns, again 4. Therefore m plus n minus 1, it is my 7. How many allocations you have? You have the total 6 allocations. Therefore your initial solution is degenerate. Fine, your initial solution is degenerate, and your initial cost is, so you can multiply them. 20 into 20 is 400 plus 1470 plus 14 420 plus 30 into 50 plus 540 plus 0 is the required answer of the problem. Look at the another one. For the unit cost, there are the three suppliers and the four demands. So firstly, we will check whether they are balanced or not. So that will be 120. It will be 25 is a 57, 40 and 23, 120. So it's a balanced problem. Fine. So once it's a balanced problem, and we can start with this allocation. Minimum value is my 4. We can put the allocation 40, 40 is a 40. Fine, there is no. Next number is 6. Fine, 50 and 23. Minimum allocation is 23. The next number is 27. Next smallest number is 7 and 7. Corresponding to this 7, there is no supply. Corresponding to this 7, there is no demand. Look at the next number is 8 and 8. Corresponding to this 8, there is no demand. Corresponding to this 8, 25 and 27. Minimum is 25. Remaining supply is my 2. Look at the next number 9 and 9. Corresponding to this 9, there is no demand. Corresponding to this 9 is a 32, but there is no supply. Look at the next number is a 10 and 10. Corresponding to this 10, there is no demand, but it's a 10. So I can put 2. Minimum of 2 and 32 is 30. The last number is 11, 30 and 30. Fine. Now you can see what is your M. M is my 3, N is my 4. Therefore, M plus N minus 1 is 6. So how many allocations you have? You can calculate the allocation 1, 2, 3, 4, 5. You have the 5 allocation. Therefore, your solution is degenerate basic feasible solution. Fine. And your initial cost will be, you can multiply them 25 into 8 plus 2 into 10 plus 23 into 6 plus 40 into 4 plus 30 into 11, and you can multiply them and get the right answer of the problem. Remember student, this cost is my only feasible cost. Fine, not the optimal one. In order to check whether they are optimal or not, you have to apply the Modi method, or called as the UV method. Look at the next one. Find the initial solutions and check whether they are degenerate or non-degenerate. Clearly say my problem is balanced problem. Fine. Now you can start with the allocations. Minimum is 1 and 1. Corresponding to this value is 7. Corresponding to this number 1 is allocation is 8. So since maximum is 8, we can start with the maximum allocation. That is my 10. Then next number is 7 and 14. This number is 7. Next smallest number is my 2, and this number is 2. Corresponding to this cost value 2, there is no available, so we can never assign them. Corresponding to this 2, 10 and 7. So allocation is 7. Fine. Next number is 3 and 3. Corresponding to this 3, there is no requirement. Corresponding to this 3 is again there is no requirement. Corresponding to the 4, we have the 4 and 4. Corresponding to this 4, we have a 3 and 5. Minimum is 3. Corresponding to this 4, we can 9 and 7. So maximum is 7. So I can put the first allocation, and then we can assign 3 and 5, 3. Clear? Then next smallest number is my 6. But there is corresponding to this 6, there is no requirement. Then next number is 7. Corresponding to this 7, there is no requirement. The only requirement is my 2. आप अपना आंसर मैं फिर बता रहा हूं, चेक कर सकते हो आप कभी भी एग्जामिनेशन में. You can see the allocation is 2 plus 3, that is 5, 8, 7. 7 plus 7 is 14. Similarly, you can check for the column wise. Then how many allocations you have? M is my 4, N is my 3, your M plus N minus 1, it is my 6. And how many allocation you have? 1, 2, 3, 4, 5, 6. You have the 6 allocation, therefore, which is equal to the M plus N minus 1. Hence, your initial basic feasible solution is my non-degenerate बेसिक फिजिबल सॉल्यूशन, और हमारा टारगेट भी नॉन डिजेनरेट ही होता है हर बार. फाइन. सो दैट मीन्स योर टारगेट इज द सॉल्यूशन degenerate? No, it's a non-degenerate solution. And you can easily find the cost, that you can multiply 2 into 7 14, 4 into 2 is 4 into 3 is 12, 8 into 1 7 into 4, 7 into 1 7 into 4. That is the right answer of the problem. Look at this another one. Suppose you have the three plants, plant 1, 2, and 3, with the respective capacities 7. Plant 2 has a capacity 12, plant 3 has a capacity 8. The plants are required to supply as a 4 different markets with the respective demands 5, 12, 6, and 4. And the cost of the shipping is given as, find the initial, your target is to find the initial feasible solution, find to minimizing the cost. So firstly, we will check whether they are balanced or not. It is my 27 and it's a 17. 17 plus 10 is 27. So it is my balanced transportation problem. So let's start with the allocation. Minimum element is my 4. Fine. So I can put the allocation corresponding to the 4 is 12, 12. Minimum is 12. Next allocation is 5. This 5 and this 5. Fine. So corresponding to this 5, the allocation is minimum of 6 and 8 is a 6. Corresponding to this allocation, 5 and 7 is 5. So we can start firstly from this case is a 6. And then you can start from here. So 5 and 7 minimum is 5. Next minimum is 6. Corresponding to this 6, there is no demand. Corresponding to this 6 is a 2 and 4. Minimum is my 2. Demand remaining is again 2. Next is 7. Corresponding to this 7, there is no capacity. Then corresponding to the 8, there is no capacity. Again, corresponding to 8 is a no capacity. Is a 10, again no capacity. 12 is no capacity. Only number left behind is 13. Fine. Now you can see all the capacity, all the demands are fulfilled. M is my 3, N is 4. What is the M plus N minus 1? They are the 6 allocations. We can see it's a 1, 2, 3, 4, 5. You have the 5 allocations. That means your initial basic feasible solution is degenerate BFS. And once is initial is a BFS, you can find the initial cost as well. 5 into 5, 2 into 6, and so on. Find the last number is plus 26 is the right answer of the problem. Calculate the feasible solution of the transportation problem. We will see firstly whether it's a balanced or not. So it's a 19 and it's a 160. It's a 30, 55. It's a 60, 40 is a 130. So clearly say this problem is my unbalanced. Then you can convert into the balanced transportation problem. What is the difference is 30. So since requirement is less, I can create a dummy column, fine, whose value is my 30. And the initial cost is my 0. So we can add a dummy warehouse W5. Now let's start with the allocations. So what is the minimum element is 0. So corresponding to these 3 0, which one is the maximum allocation? 30 and 50 is a 30. 30 and 40 is 30. 30 and 70 is 30 again. So you can put any one. So I can start with the first number. Fine. The next number you can start from here. Next 0, but there is no requirement. So skip that. Next smallest number is 7. 7 is my 20 and 15. Minimum is my 20. I can substitute here. Next number is 8. There are the two 8s. Corresponding to this 8, there is no capacity. Corresponding to this case is my capacity is at 30. Requirement 30 and 70. So that is my 30. Next number will be, next smallest number is my 9. Corresponding to this 9 is 40 and 40. Minimum is 40. That will be cancelled out. Next number is 10. Corresponding to this 10, 15 and 40. Minimum allocation is 15. And this number is my 25. Next allocation is 11, correspond to the 11 there is no capacity. Then for the 12, 25, but there is no capacity, there is no requirement. This is my 12, but again you can see there is no requirement. Next number is minimum is 18. No, this 18, there is no requirement. Fine. Then is a 21. No, that says 16. 16 is my 25 and 25. Allocation is 25. And then, sorry, this number 30 will be cancelled out. 30 and 40 is a fine. Now you can see all are over. So what is the M? 3. N is my 5 because this problem is my balance. M plus N minus 1 is my 7. So how many allocations you have? 1, 2, 3, 4, 5, 6. So that means your solution is degenerate basic feasible solution. And once you can get the degenerate, you can get the cost value. 20 into 7, 25 into 16, 5 into 10 and so on is the required initial cost of the transportation problem. Find the initial basic feasible solutions to maximize the profit. You can see your target is to maximization. Fine. So you firstly convert into the minimization. How you can convert the minimization? Again, whether they are balanced or not, we will check it later. Firstly, we convert the maximization into the minimization and then we will check whether they are balanced or unbalanced. Is it clear? Now, how you can convert the maximization into the minimization? Look at the cost values. Look at the cost values and pick the largest number. Pick the largest cost from the table. What is the largest cost is? 44. Then you can subtract 44 from the each number. Fine. Like this number is my 44 minus 44 minus 44 minus 44 minus 38, 44 minus 35, 44 minus 28, 25, 44 minus and so on. Fine. And once you can subtract them, you can see the first number becomes 4. 44 minus 25 is my 19 and so on. And now you can check whether these are balanced or unbalanced. Clearly say that my problem is unbalanced. Fine. Then you can convert into the balanced problem. How you can add? You can add the dummy column with the cost allocation 45 because the difference is my 45. Now once this problem is my minimization and the balance problem, we can apply the northwest corner method. So let's start with the initial value is a 0. The corresponding allocation will be 30. Fine. Corresponding this allocation is a 45. Fine. Corresponding to this allocation is a 30. Corresponding this allocation is a 45. So that means the maximum value will be 45. That is either you can write at this point or at this point because both the allocation will give you 45. So I can use any arbitrary value. Let's say 45, this number. This point is my 55. Now the next number will be 0, 30 and 45. Minimum is 30. Again for this 0 there is no supply. Again for this 0 there is no demand. Next smallest number is my 4. Corresponding this 4 is 55 and 15. I can put as a 15. This number is my 40. Next smallest number is my 6. Corresponding to this 6 there is no demand. Corresponding to this 6 is my 20 and 70. Minimum allocation is 20. Remaining is 50. Next allocation is my 9. Corresponding to this 9 is a 20. There is no minimum, there is no demand. Next number is my 11. Corresponding to this 11 is a 30 and 40. The minimum value is 30. Next number is 14, but there is no demand. Again, there is no demand. Corresponding to this 14, again, there is no supply. 16, there is no supply. Fine. Then it will be 16. 16 will be 50 and 60. So that number is 50 and now 10. And the last number is 10 and 10 is my allocation. So your answer will be m is equal to 3, n will be 5, then m plus n minus 1 is my 7. You need a 7 allocations for this problem. So we will see how many allocations you have. 1, 2, 3, 4, 5, 6, 7. So yes, you have the non-degenerate BFS solution. And you can find the cost. That cost will be 15. That is 15 into the initial cost. Initial cost of the problem is 40, 40 plus, because this problem is my minimization. Next number is 10 into A to C, that is 22. 10 into 22. Fine. And then similarly for the other case, and you will get the maximum maximum profit of this particular problem. Okay, the company has the two plants located at Mumbai and Kolkata with a weekly capacity. This is my capacity of 200 units and 100 units. The company supply the air cooler to the four showrooms located at Patiala, Delhi, Lucknow and Kanpur with the capacities. This is my demand 100, 100 and 30. And the cost of the transportation. So that means my problem is minimization. So we will see whether this problem is balanced or not. You can see clearly say the problem is my unbalanced. Fine. So once it's unbalanced, you can convert it into the balanced problem. There is a requirement to add the city. I can use the dummy zeros with the allocation capacity 5. Now this problem is my balanced problem as well as the minimization. So we can start with the allocation. So let's start with the 0. It's a 5. सभी में 5 5 ही आएगा minimum. I can start with the random number 5. Fine. Now you can see 0 0 will not be possible. Next smallest number will be my 80. It's a 50. So it's a 70 and 100. 70, 30. Next smallest number is my 70. 100, 30. Fine. Next smallest number is 85, but there is no capacity. Now the next number is 90 and 90. For this 90, there is no demand. 70 and 120. It's a 130. Minimum is 70. Then 100, because this will be the maximum. And the last number is 30 and 30. So your M will be number of the, there are the 3 rows. N is the number of the columns. Then M plus N minus 1 is my 6. So how many allocations you have? 1, 2, 3, 4, 5, 6. So yes, you will get the non-degenerate BFS solutions. And you can find the initial transportation cost will be 70 into 90 plus and so. Fine, ये तो आप कैलकुलेट से इजिली कर सकते हो. Okay, again you have the 3 different cities A, B and C, and their monthly capacities are 50, 50, 150 and 20. And you have to find the initial cost by the help of least cost method. Clear? अभी तक क्या था, आपको ये टेबल पहले से बनाया था सब केस में भी. Look at that table is given to you in each case. Look at in this case also the table is already given to you. अब यहाँ पे आपको टेबल खुद से बनाना है. Fine. How you can generate the table? Again, it's a very simple. How many? A, B, C, and these are my D, E, and F. Fine. Now you can see what is the A. The city A has capacity 50. I can write this is my capacity. The city B has 150 capacity. City C has 200 capacity. Similarly, the monthly requirement of the D is my 100. It's a 130 and 20. What is the cost of the transportation? That is the shipping cost from A to D. This is the shipping cost given as a 2. Similarly, A to E, the shipping cost is my 1. The shipping cost from A to F is my 4. Similarly, you can write for the B. B to D is my 3. B to E is my 1, B to F is my 2, and so on. So we can convert this matrix here. Now you can check whether this problem is balanced or not. This number is my 400 and this number is my 430. That is an unbalanced problem. So once it's unbalanced, we can add the dummy city A, B, C called as the C star. Fine. M will be my 4, N will be my 3. So your M plus N minus 1 will be 6. Now let's start with the allocation. Minimum is my 0, 0 and 0. So it's a 30. Fine. That is my 70. Next 0 and 0 will be ruled out. 1 and 1 both have the same value. Look at the maximum allocation. Corresponding to this number is 50. Corresponding to this one is my 130. So I can put the maximum allocation at this point. So 130, it is my 20. Now corresponding to this one, now it is not possible. Why? Because there is no requirement. Next number is my 2. Corresponding to this number is my 20. Corresponding to this 2 is my 70 and 50. Maximum is my 50. So I can put 20. Oh, now next number is my 2, 20 and 200. It's a 20, 180. Fine. Next number is my 4, but corresponding 4 there is no capacity. Corresponding 5 is a 20 and 200 is a 180. And the last is 6. There is no requirement. It's a 7, 180, 180. Last number आपका proper cancel होना चाहिए. So how many allocations you have? 1, 2, 3, 4, 5, 6. Fine. So you can write every answer in your examination is x1 is 1 is 50. This number will be second row, second column, 130. Second row, third column is 20. X31 is my 20. X33 is my 180. X41 is my 30. So that means we will get the non-degenerate BFS solution. And you can calculate the cost by multiplying 50 into 2, 130 into 1, and so you will get the required answer in the problem. Look at this next one. There are the three parties, party 1, 2, and there are the customers. So what is the party 1 turn is 14, party 2 is 10, 12, 5. Similarly for the customer A 10, 20, 10, 6, 10 and 15, and your target is to minimization. Fine. So check firstly whether they are the balanced or not and clearly say it is my balanced problem. Once this is the balanced problem, we can start with the allocation. So minimum cost is 1, 5 and 6. Minimum is 5, remaining 1. Next is my 2, but there is no supply. Next number is 3, 15 and 12. Allocation is my 12. Next is 4, 4. Corresponding this 4, allocation is my 3. Corresponding this 4, there is no allocation because there is no supply. So I can substitute 3, 11. Fine. Next smallest number will be my 6. Corresponding to this 6 is a 1 and 11. Allocation is my 1. Corresponding to this 6, but there is no supply, so there is no number. I can put as a 1 and this number is 10. Then is a 8, 10 and 10. Fine. Correspond 9, it is not possible. And so what is my M? M is my 3, N is my 3. What is the answer of the M plus N minus 1? 5. Therefore, allocations are, allocation means that is the initial allocation. Initial feasible allocations are x11 is my 1, x12 is my 10, x13 is my 3, x23 is equal to 12, x31 is equal to 5. Since we need a 5 allocations, how many are there? There are again 5 allocations. Therefore, the initial feasible allocations are non-degenerate basic feasible solution. And you can calculate the cost is 6 plus 80 plus 4 into 3 plus 12 into 3 plus 5 into 1, and you will get the required answer of the problem. Fine. So this is a very simple way. You can see that all those examples that we have covered in this lecture, the same examples we have explained with the help of the northwest corner method as well. For more lectures on the northwest corner least score, you can see the combined lectures. Until then, you can do these 4 problems as an exercise for you. You can try to solve it by on, like question number 1, check whether it's a balanced or not, and then let me know whether they are the degenerate or the non-degenerate. Similarly, these are the third and the fourth example. This is an exercise for you. You can solve it and let me know in the comment box whether you are able to solve the problems with the help of the least cost method or not. If you need any help from my side, you can tell me. I am ready to help you at any time. Next lecture, we will see the 15 plus examples of the WAM methods, Vogel approximation method. Till then, you can share this video with your friends, like and comment on the video. Happy learning always. Best of luck, students. Thanks for the watch.